will again calculate m dash BA. So m dash BA is, what is the value? So m dash BA is minus 0.22. So it is minus 0.22 into what value is there? What is the value? Next value. Please tell the value. What?
16.15, sir.
Uh, Wait, one moment. Yeah, it is the cycle 3. So minus 0.22 into 16.14 plus. What is the value for this one? So it is m dash AB is as usual 0 plus m dash CB. Okay. So it is 0 plus how much is m dash CB we got? We got m dash CB as
4.66.
4.32 if I'm not wrong.
So that is cycle 1.
Wait. M dash CB. M dash CB is, yeah. Sorry for that. So it is 4.66. 4.66. Okay. So please calculate how much you are getting. Then I will have M dash BC. So M dash BC equals to minus 0.28 into 16.14 plus 0 plus 4.66.
Minus
Okay.
4.57, sir.
So the first one is minus 4.57 kilonewton meter, and the second one is minus 5.82. Is it correct? Please check.
Yes, sir.
Okay. Next, so after m dash BC, I will again calculate m dash CB. So m dash CB equals to minus 0.28 into minus 10.94. Then this one minus 5.82 again. So minus 5.82, that is m dash BC. Then plus m dash DC is 0. Okay. So how much is this one? Please calculate. Next I will calculate uh, next I will calculate m dash CD. So m dash CD equals to, I'll just change the rotation factor. It is minus 0.22 into the same value, that is minus 10.94 minus 5.82 plus 0. Okay, so how much is this one? It is coming. Is it 4.69 kilonewton meter?
Yes, sir.
And this one it should come 3.68 if I'm not wrong. Please calculate.
Yes,
Is
sir.
it
3.68.
okay? So now these values I will write it here. Okay, so the first one is minus 4.57. The next value is minus 5.82. Next value is 4.69. Next value is 3.68. Please correct me if I'm wrong anywhere. Okay, you are free to do so. Okay, so again here by default these values for the rotation contribution for the fixed ends will be 0. Okay, so this is our cycle 3 is complete. Okay, so in cycle 3 also you see like the value is somewhat coming closer. Okay, so again we need to go for the cycle 4. Okay, so let's go to the cycle 4. So again we need to follow the same principle. Okay, so wait, yeah, cycle 2, this is cycle 3, and now it is cycle 4. Okay, so for cycle 4 again we will calculate the m dash BA. So m dash BA equals to minus 0.22 into 16.14 plus 0 plus what is the value? Next value is, what is the next value?
4.69, sir.
4.69. Okay, so please calculate how much that will be. Next after m dash BA, we
Minus
will
4.58 kilonewton meter.
minus 58 kilonewton meter. Okay, next m dash BC. So how much is m dash BC? Please calculate m dash BC. So,
Minus 5.83.
so it is minus 0.28 into 16.14 plus 0 plus 4.69. Okay, so how much it is coming? Minus 5.83. Okay, next one is m dash CB. So m dash CB is minus 0.28 into minus 10.94 minus 5.83 plus 0. Okay, so please calculate how much is that one. Then m dash CD. Okay, m dash CD equals minus 0.22 into
4.69.
uh, minus 5.83 plus 0. So it is minus 4 point, sorry, not minus,
Plus
it is
4.69.
4.69 kilonewton meter. Here also kilonewton meter. And this one is, how much is this one?
3.68.
Again, 3.68 kilonewton meter. Okay, so again we will write all these values here, right? So in cycle 4, the first value is minus 4.57, the second value is minus 5.83, and the third value is 4.69, and the fourth value is 3.68. Okay, so here you can see almost these values are converging. So again, if you want, you can go to one more cycle so that this one we may converge. Okay, no need to do that. Also, only it is 5.82 and 5 minus 5.83. Okay, so no issue. So we can stop the iteration here. Okay, so now the rotation movements will be for m dash AB, it is 0. Okay, this is your final answer. And for m dash BA, it is this one. So I'm highlighting these results. Okay, so m dash BA is minus 4.57, m dash BC is minus 5.83. So just a moment. Next we have is m dash CB is 4.69 and m dash CD is 3.68. Okay, and here we will have again this value as 0. Okay, so now in the next step, that is the fourth step. Okay, so in the fourth step we will calculate the final end moments. Okay, so you can write, you can give the heading as I was using the black ink. Okay, that is step 4, and in step 4 I have the final end moments, right? Have the final end moments. Okay, so so how we will find out the final end moments? So the final end moment MAB equals to, I have the equation MFAB plus 2 times of M bar AB plus M bar BA. Okay, this formula we will use in order to find out the end moments. Okay, so now please tell me how much is MFAB? MFAB is how much?
Minus 1.77.
Okay, so it is minus 20.83, then plus M bar AB is how much is M bar AB? M bar AB is 2 into 0, then plus M bar BA is how much is M bar BA? we have written here M bar BA is minus 4.57. Okay, so it is minus 4.57. So please calculate how much is the total value. Please calculate the total value.
Minus 25.4.
Minus 25.4 kilonewton meter. Okay, so similarly, MBA, the moment at the end support or the moment at the support BA will be equals to MFBA plus 2 times of M bar BA plus M bar AB. So please put the value. So it is plus 20.83 plus M bar BA is 2 into minus 4.57 then plus 0. So please find out how much is MBA. Next I have MBC. MBC equals to MFBC plus 2 times of M bar BC plus M bar CB. So how much is MBA? What is the value?
11.69.
11.69 kilonewton meter. And how much is MFBC? MFBC is, I forgot. Wait. MFBC is minus 4.68. Okay. Sorry. Minus 4.68 plus how much is M bar BC? How much is M bar BC?
Minus 5.83.
Minus 5.83. Then plus M bar CB. How much is M bar CB? M bar CB is minus.
Plus, sir, plus 4.69.
Sorry, plus 4.69. 4.69. So please tell me how much is the value. Calculate and tell me the value. MFCB plus twice of M bar CB plus M bar BC. Okay, so it is so MFCB is 14.06 plus twice of M bar CB is M bar CB M bar CB is into 4.69 then M bar BC is minus 5.83. So how much is this one? Please calculate. Okay, how much is MBC? Moment at BC?
Minus 11.65 kilonewton
Minus
meter.
11.65 kilonewton meter. Okay, so this one should, okay, next one. How much is MCB?
$17.61, sir.
17.61 kilonewton meter. Next, next I will go to the MCB. After that, MCD equals to sorry MFCD plus twice of M bar CD plus M bar DC. Okay, so please put the value and find out. So MFCD is minus 25 plus twice of M bar CD. How much you got? M bar CD is into 3.68 and M bar DC is 0. Okay, so similarly MDC equals to MFDC plus twice of M bar DC plus M bar CD. So it is 25 plus 2 into M bar DC is 0 plus MC, this one is 3.68. So what is the value? Please tell if you have calculated.
MCD is minus 17.64 kilonewton meter.
Okay,
MDC is 28.68 kilonewton meter.
kilonewton meter, right? Okay, so now we have determined the moments. Okay, now after this, what we will do? How we will find? Oh, like how? So we will go back to the question. Okay, we'll go back to the question and see what it has asked to do. So it has asked to analyze the beam as shown in the figure below using Keynes method and also draw the bending moment diagram. Okay, so we have found out the support moments and now we'll go to the bending moment diagram. Okay, so in order to do that, let us draw the beam first again. Okay, okay, next this one, again this one, and here I have this one. Okay, so here I have a UTL and here I have a point load of 25 kilonewton. Here I have a point load of 40 kilonewton and this one, this length is 5 meters. This length here it is 3 meters and this one is 1 meter and this one it is 2.5 and this one it is again 2.5 meters, right? Okay, so now what is the next step? The next step is we need to plot the values. Okay, so I'll just I'll use some other ink. Okay, so now let me take the blue ink. Okay, so now I will plot the end moment. So how much? So this is A, this is B, this is C, this is D. Okay, so how much is MAB? How much is MAB? Anyone can tell the value? How much is MAB we got?
Minus 25.4.
Minus 25 point.
25.4.
Okay, so if it is minus 25.4 means how it will be? Who can say? Whether it will be on the upper side or in the bottom side. Okay, let us put the value first. Okay, so it is minus 25.4. Okay, so if it is minus, so first let's plot here. So it is, how much is the value? Minus 25.04.
4.
04 or 25.4?
25.4.
Okay, 25.4. Next, what is the next value? Next value is
MBA is 11.69.
11.69. Okay, so it is 11.69. Next value?
MBC minus 11.65.
Okay, it is again 11.65. So it is almost 11.69. Okay, 11.69. Okay, next MCB
MCB 17.61.
17.61. 17.61. Next MCD.
Minus 17.64.
Yes, by 17.64. So it is almost 17.61. Okay, next how much we got? MDC
MDC 28.68.
28.68. Okay, so now similarly, so here it is 20, this one. So the first, let us say this level is 25.4. Let me erase this. 25, sorry, 25.4. Next we have is 11.69. Okay, so it is 11.69 or 64. Yeah, 69. Okay, next I have is 17.61. Next I have is 28.68. So this is 28.68. Okay, now in between you need to put which color I will use. I will use this color. Okay, so here, so due to this UDL, the bending moment here will be what will be the shape of that bending moment? It will be in the
Parabola.
parabola. Okay, so what will be this value? So it is WL square by, what is the formula? Bending moment WL square by 8. Okay, so W is, how much is W? It is this one I didn't mark, 10 kilonewton per meter. So 10 into L is 5 square divided by 8. So please calculate how much it is. 10
31.
into 5 square by 8. So how much is the bending moment value?
31.25.
31.25. Okay, now due to this point load or due to this eccentric load, what will be the bending moment value? It is W AB by L. Okay, so W is 25 into A is 3 into 1 divided by L is 4. So please calculate. This is
18.75.
18.75 kilonewton meter. Kilonewton meter. Okay, so 18.75 means just above this one. It is 18.75 kilonewton meter. Okay, next one, due to this point load, what will be the value? It is W L by 4. So W is 40. Sorry for that. It is 40 into L is, how much is L?
5.
5 meters divided by 4. So please calculate how much is the bending
50.
moment value. Come again.
50, sir.
50 kilonewton meter. Okay, so it will be well above this one. This is 50 kilonewton meter. Okay, so let me use some shading to shade this one. Okay, so I'm showing the negative portion with this pink color. Okay, and here also I will have the negative value. Next, here I'll be having the negative value. Next, where else I'll be having negative value here. Okay, so I'll use some other color. Let us say this one. Okay, now which one will be my positive ones? So for positives, I'm showing it with green. Okay, so this area will be for my positive bending moment. Similarly, this area also, and this part. Okay, so this will be my positive, right? So this is the solution of the problem which is being asked. Any doubts till now? Any doubts? Hello? Anyone having any doubts? Please respond.
No, sir.
No? Okay. And one more thing. In the previous class, many students, they didn't understand this topic. Shall we revise it once again? Because another few minutes is left, and with those few minutes, we cannot cover a complete problem. Okay. So it is better if we revise. What do you say? Shall we revise this one once again?
Okay, sir.
Okay, so all of you, those who have not or those who didn't attend the previous class, please pay attention now. Okay, you can, if you pay attention properly now, definitely you will get this problem easily. Okay, it is very easy. Okay, so see here. So in the first problem, so or in this problem, we were given, so we have to analyze this beam using the Canis method, and also we need to draw the bending moment diagram for the same. Okay, so first, in the first step, what we will do, we will see the figure, and from that we'll find out the fixed end moments. Okay, right? So we have find out the fixed end moments. So for the span AB, the fixed end moment value is, or what is the formula for that one? It is minus WL square by 12. So W is here 10, and the span is 5 meters, and WL square by 12, it is coming out to be 20.83. Okay, so similarly, the MFBA will be plus WL square by 12. So directly I have written it as 20.83. Okay, next we have a point load, eccentric point load. Okay, so in order to find the fixed end moment, for that one, the formula we require is minus W AV square by L square. So W here is 25, A is 3, and B is 1 meter here. Okay, so 1 square divided by 4 square. So it is coming as minus 4.68. Okay, so similarly we will calculate MFCB. So MFCB will be just W plus W A square B by L square. So we'll just put the same values, will include the same values, and we are getting the fixed end moment MFCB as 14.06. Okay, next we will calculate for the span CD. Okay, so for span CD, it is having a point load, and it is at a distance of 2.5 meters from both the ends. Okay, so the formula will be minus W L by 8. Okay, so if you want, you can put we can put this value also, you will get the same result. Okay, so W minus WL by 8, so W is 40, L is 5 meters, and and this is 8, so it is coming as minus 25 kilonewton meter. Okay, so similarly MFDC will be plus 25, so it is plus WL by 8. This is not square. Okay, this is not square, this is, I'm just putting a tick mark here. Okay, many students they got confused, sir, this is square, this is not square, this is only the tick mark. Okay, many of you we answered the same manner in the previous class also. Okay, so now we have calculated the fixed end moments. So after we calculate the fixed end moments, just like the moment distribution method, we will calculate the relative stiffness. Okay, we will calculate here the relative stiffness, and along with that a new concept is there, that is the rotation factors. And what is the value of how to evaluate the rotation factors? So the rotation factors values will come from the distribution factor itself. So what is the value for rotation factor or rotational factor, whatever may you call? So it is minus df by 2. So what is the whatever you get the distribution factor, that divided by 2 with a minus sign will give you the rotation factor. Okay, so as here in this problem we have two continuous ends, that is a support B and support C. So that's why here we will have two, so we will write about two joints, and in those two joints the members, those are BA and BC, are connected to support B, and to support C we have CB and CD. So that is what we have written here, BA, BC, CB and CD. Okay, now we will calculate the relative stiffness for all the members. So since the member BA, so in member BA, what is the far end? What is this type of support for the far end? So it is a fixed. Yes, A is the far end. So and the end A, it is fixed. So what will be the formula for relative stiffness? 4 EI by L. Okay, so that is what we have written, 4 EI by L. Okay, so 4 EI, and the value of L is 5 meters. So it is coming as 0.8 EI. Okay, now let's go to now let's go to BC. Okay, now BC. So what is the far end? The far end is here hinged. Okay, but if the condition, one condition is there, that if the far end is a continuous support, then we will consider that as fixed. So that's why this B, so this C, that is the far end for BC, is considered to be fixed. The support C is considered to be fixed. So that's why here we have, it is what is, so what will be the formula for the relative stiffness for BC? What will be the formula for the 4 EI by L? Okay, so similarly here it is again 4 EI by L. Okay, so 4 EI by L is 4 meters. So it is coming as EI. Okay, now so the total stiffness is 0.8 plus 1 EI. So it is 1.8 EI. Okay, now the distribution factor is this one divided by the total distribution factor. So 0.8 by 1.8 EI. So it is coming as 0.44. Okay, now similarly for the distribution factor for this one will be 1 by EI, or sorry, 1 EI by 1.8 EI. So that is 1 by 1.8. So that is coming to be 0.56. Okay, now the rotational factor will be, what is the rotational factor value? It is minus of half of the distribution factor. Okay, so distribution factor is 0.44. So minus 0.44 by 2, that is minus 0.22. Okay, similarly here we have minus 0.56 by 2, that is minus 0.28. Okay, so similarly now let us go to CB. Let us go to CB. Okay, to join C. So in CB, okay, the near end is C, the far end is B. Okay, so now for CB, what is the relative stiffness value? What is the relative stiffness value? Huh? 3 by L. How 3 by L? I told, right? If the far end is a continuous one, means after this we have one more support or one more end. Okay, support condition. Then we will consider again this one as fixed. Okay, so that's why here again it is 4 EI by L. Okay, so 4 EI, L is 4 meters, so it is 1 EI. Okay, now let us go to the next support, that is CD. Okay, or the span CD. So for the span CD, the far end is fixed. So if the far end is fixed, what is the relative stiffness value? What is the relative stiffness value? Anyone? What is the relative stiffness value?
4 EI by L.
4 EI by L. So that's why here we have 4 EI by L. So it is 4 EI by 5. Okay. So if we calculate this one, so 1 EI and 4 EI by 5. So it is around 0.8 EI. Okay, so the total is again 1.8 EI. So 1 by 1.8 EI, it is 0.56. So here it is 0.8 divided by 1.8 EI, so it is 0.44. Okay, now the rotation factor will be minus half of this one, minus half of this one, so it is minus 0.28, and it is minus half of this one, that is minus 0.22. Okay, so all these values we will write in the Canis table. Okay, so next we have is the Canis table. Okay, so we will make a Canis table. So if the support ends will be fixed, okay, and wherever we have a continuous end, there we will make boxes. Okay, so and inside it again we will make an box and we will join the sides for that one. Okay, now what does this say? So it says that suppose if here we have another, suppose here we had one more support. Don't do anything, just listen. Okay, suppose here we had another support, then we could have written here. Okay, here suppose we had another support, we could have written that for those the distribution factors for those here. Okay, so that is why those boxes are being given. Okay, so the first one is, so here we write the fixed end moments. So how much is MFAB? MFAB is minus 20.83. How much is MFBA? It is 20.83. How much is MFBC? It is minus 4.68. How much is MFCB? It is 14.06. How much is MFCD? It is minus 25. How much is MFDC? It is plus 25, right? So we have written all those values here. Now what we will write inside this one? So inside this one we will add these two values. So we will add MF BA plus MFBC. So whatever we get the summation value, we will write it here. Okay, including the plus or minus sign, whatever we get that we will write it here. So similarly here also we will add these two. So this one we will add and this one we will add. So it is MFCB plus MFCD. Okay, that value we are getting as minus 10.94 and we will write it here. Okay, now what we will write here? So here we will write the, what is this one? It is the rotation factor for BA. Rotation factor, here I will write the rotation factor for BC. Here I will write the rotation factor for CB, and here I will write the rotation factor for DC. Okay, so after that what I will do? After that I will go to the next step, that is, oh sorry, not next step, here in the step 3 I will calculate the rotation contribution. Okay, so here how I will calculate the rotation contribution? So the rotation contribution is given by M dash. Okay, so M dash equals to the rotation factor into the summation of the fixed end moments at that joint plus the summation of the far end rotation contribution values. Okay, now what is this rotation contribution values that we will calculate subsequently. Okay, now see this one. So the first one is m bar BA. So always remember that we will calculate the rotation contributions for the ends where the beam is continuous. Okay, so first we will calculate m bar BA. So m bar BA is, what is the formula? It is the rotation factor into this value. Okay, rotation factor into the sum of the fixed end moments at that support. Okay, so that is 16.15 plus m bar AB plus m bar CB. Okay, so now for the first cycle we didn't know what is the value of m bar AB and what is the value of m bar CB. Okay, so that's why for the first cycle we will take those values as 0. Okay, this one you can see it is 0. Okay, so we will do the calculation and we will find out m bar BA. Okay, similarly we will calculate for m bar BC. Okay, so for m bar BC means again it is corresponding to support or joint B. Okay, so for joint B, as I said, I will always consider m bar AB plus m bar CB. Okay, so that's why I will just, so here in short I will just change the distribution factor. Okay, so sorry, the rotation factor. Okay, so the rotation factor is minus 0.28 into this value, the same value 16.15 plus m bar AB plus m bar CB. Okay, so now since these values are 0, I will put 0 and I will get the m bar CB. Okay, so m bar CB is this one I have written here. Okay, so m bar BA I got as minus 3.55. I have written it here. M bar CB value, sorry, BC value I have got minus 4.52. I have written it here. Okay, now next one I will find m bar CB. Okay, so m bar CB will be, so m bar CB equals to again the rotation factor for that one, then into the sum of the fixed end moments, then plus m bar BC plus m bar DC. Okay, so m bar BC plus m bar DC. Okay, for this joint whenever we are calculating we will use these two values only. That's it. Okay, and depending upon the span, if it is m bar CB, I will use the rotation factor of CB. If I am calculating m bar CD, I will use the rotation factor for CD. Okay, that I will only use and I will get, so here I get minus 0.28 into this one, so it becomes 4.32. Similarly m bar CD will be, again I will only change this one. You can see this value over here, it is same here also. Okay, this value over here it is same, so I'm just changing the rotation factor and I'm getting this value. Okay, so similarly I will write all those values. Okay, and I will do this calculation or cycle wise unless and until I get these these values, these values, these values and these values same. Okay, unless and until till that we will go on, keep iterating and we'll get the, so when we get same results, that will be our final answer for the rotation contribution. Okay, so for the fixed end it is the rotation contribution is 0 always. Okay, so now we have calculated this one, so now these values we will take to calculate the end moments. Okay, so in the next step, that is step 4, we will calculate the end moments. You can see. Okay, so final end moments I'll calculate. So final end moments will be given by MAB equals to MFAB plus twice of the rotation contribution by M bar AB and one time of the rotation contribution of M bar BA. So I will put all these values and I will get the end moment. Okay, so similarly I will find for BA, so it is MFBA plus twice of M bar BA plus M bar AB. So I'll get this value. Next I will again find for MBC. Okay, so MFBC plus twice of M bar BC plus M bar CB. So I'll get one value, that is the moment at BC. Okay, next MCB. Okay, so again it is MFCB plus twice of M bar CB plus M bar BC. Okay, so I'll get one value. Okay, so similarly next I'll calculate MCD. So MCD equals to MFCD plus twice of M bar CD plus M bar DC. So I'll put all these values and I will get this one as MCD. So similarly I will calculate MDC. So it is MFDC plus twice of M bar DC plus M bar CD. So that I'm getting as 28.68 kilonewton meter. So after this I will put all these values. Okay, whatever moments I'm getting, I will put all these values. And for the bending moment diagram, I'll just simply draw this one and I will put all the support moments. And then for each span, I will calculate the bending moment, the maximum bending moment, and I will plot the same. Okay, that is the explanation for this problem. Okay, so in the next class, we will start the third unit. Okay, and again I will give you some assignments related sorry, and that assignment has already been given, but I will club some of these as problems in your next assignment when I will give that after the end of the third unit. Okay, so that's it for now.